So we're going to start off with learning how to solve logarithms, how to solve logs. Then after we solve logs, we're going to move on to solving exponentials. Okay. Now, there are two types of equations you can have dealing with logs. One is where you have multiple logs within the equation, and the other is when you have a log set equal to a number. We're going to do the first, where we have a log set equal to a log. Step one is to condense the logarithms on each side of the equation so that there's only one log on each side. So in our first example, do we have just a single log on each side of the equal sign? On number one. Yes, so we're good to move on to step two. If you have two logs set equal to each other that have the same base, for example, log base b of x equals log base b of y. If they have the same base, this means that the arguments, the x and the y, are actually equal to each other. And you can just cancel the logs. So in this example, we have log base 3 of 7x minus 1 equals log base 3 of 5x plus 17. We have a single log on each side. Now what can we do? Yes, because and only because they are log of the same base, this means that 7x minus 1 must equal 5x plus 17. They must be equal to each other. There's no other way that this could work out, that these two sides could be equal. So now what do you think you do? You solve for x. You get the x by itself on one side and the constant by itself on the other. It's a linear equation. So what do you want me to do first? We can add them over, sure. So we have 17 plus 1. So we have 7x equals 5x plus 18 when we add the 1. And then we can subtract the 5x. So we have 7x minus 5x, which is equals 18. And then we divide both sides by 2 to get the 2 off of the x. So what do we have?
X equals 9.
X equals 9.
This makes sense.
How do we check for extraneous solutions? We do have to. Sometimes with log, we could end up with an extraneous solution. What is an extraneous solution? What's an extraneous solution?
When you plug in the x and it makes it so it doesn't, makes it so it's untrue.
Exactly. When we solve for x, we do all the work solving for x, but then when we plug it in, the two sides of the equation are not equal. So let's go ahead. Now, I'm going to check this by plugging in 9 for x. So we have log base 3 of 7 times 9 minus 1 equals log base 3 of 5 times 9 plus 17. Do you think I'm doing this all in my head?
No.
Nope, I'm pulling out my calculator. How do I get log base 3 in my calculator? What do I press? Math. Then what? Up to, I think in your calculators it might be different. Is it A for you guys? Okay, so you go to math and then you go up to A and you press enter. And then you just type in log base 3 of 7 times 9 minus 1. And you figure out what that equals. 3.76. And then you do the other side. Log base 3 of 5 times 9 plus 17. And we also have 3.76. So is this extraneous? No. Plugging in works. Our solution is x equals 9. Number 2. Any questions on number 1? Number 2. We have log of 4 plus log of c plus 3 equals log of 8. How is number 2 different from number 1? You have more logs. What did step 1 say to do? Yes. You need to condense on one side so that you have a single log on both sides. How can we condense log of 4 plus log of c plus 3? This is why we learned what we did last class. How do we take two logs that are being added and condense them to a single log? Multiplication of the arguments. So we take 4 and c plus 3 and we multiply them. So we end up with log of 4 times c plus 3 equals log of 8. Do these logs have the same base? They do. There's an invisible 10 on both. So that means what can we do? And just write 4 times c plus 3 equals 8. I want you guys to finish solving this one. Lily, what did you end up getting for c? Let's see. Yes, I believe you are right. C is equal to -1. Now, when we plug this in, -1 in for C, was it extraneous? Because our base is 10 here, you can just hit the log button right next to the 7. Log of 4 plus, log of 4 end parenthesis plus log of -1 plus 3 is just 2. 9.903. And then we just have to check log of 8. Which, yes, does equal 0.903. So is this extraneous? No. C equals -1 is our real solution. Okay. Any questions on these two types of problems? When we have a log set equal to a log. Okay, now for the next type. Which, cross out number 10. We're not even going to look at number 10. Don't worry about it. Number 7. Well, let me do the hardest one. Let me do number 9. This should feel somewhat familiar to you because you did something similar when you found inverses. Yes, Eli? Yes. We need to first, that's step 1, get the log all by itself on one side. So we need to add the 5 over in number 9 first. So we have -3 plus 5, which is 2. So we end up with log base 6 of w plus 7 equals 2. Can I now subtract the 7? No. The 7 is within the log. You must now undo the log. How do you undo a log? What is the opposite operation? Exponential. So what do we do? You take a big base of 6. Because the log has a base of 6, you take a big base of 6 on both sides. So 6 raised to the power of log base 6 is actually 1. And then that w plus 7, it's actually an exponent on the 6. But we now know that for a log, exponents can become the coefficients. So that's why we can be left with w plus 7 equals, what is 6 squared? 36. Now what? You just solve for w. So you subtract 7. And what does w equal to? 29. What do we need to make sure to check for, though? So we have log base 6 of 29 plus 7 minus 5 equals -3. So in my calculator, I'm going to press math A, log base 6 of 29 plus 7 minus 5. And I want this to equal what? -3, which it does. So this is not extraneous, and I can circle w equals 29. You guys try 7 and 8. Mateo, on number 7, what did you do first? Good. And how did you get rid of the log? You created a big base of 2 on both sides. Good. So we're left with 3x minus 4 equals, now what is 2 to the 7th power, Kaylee? 128. Good. What did you do from there, Ava? Yes. And we got 132. Then what did you do from there? No Savannah today. Addison. Yeah, you divide both sides by 3. And what was our final answer? Perla, what did you get? Oh, did you know I called you? Or else then you're staring at you. I'm so sorry, Perla. Yeah. Oh, that was so funny. That's okay. Oh, no. Addison's even pointing to your paper. Oh, that's funny. Okay. Oh, no Richard today. Okay. And then Yuri, when you checked if this was extraneous, was it extraneous? When you plugged that 44 back in? No, it was not. Good. When we plugged 44 in, we ended up with this entire left-hand side equaling 7. So no, it was not extraneous. Good. Any questions on number 7? Number 8. What did you do first, Aiden D? Yes, big base of E on both sides, and then the log and the E cancel, leaving you with just 2A equals. Now, what was E to the 9th power? Marisol. In your calculator, you can just hit second ln E to the 9th. Perfect. 8,103. And then what did you do next, Oscar? It's okay. So we have 2A equals 8,103. What do we do to get the 2 off of the A? Yes. We divide both sides by 2. And we get A is 4,051.54. When you checked if this was extraneous, was it extraneous, Kennedy? No, it was not. ln of 2 times 4,051.54. Now, to plug this in my calculator, what I hit is ln of 2. And then in my calculator, because I already have that 4,000 number, what I do is I hit the up arrow key to highlight over it. Well, actually, I put a times. Up arrow key to highlight over it, and then I press enter, and it brings the entire number down. In math, you should be using the entire numbers until you round in the very end. Because look, if I had just typed in ln of 2 times 4051.54, thank you. Times, does it give me exactly 9? No, this is because you rounded too early. That's why I always bring it down using my calculator's amazing functions. There are actually 3 different types, though. There's one where we have an exponential set equal to an exponential, and they have the same base. There's another where an exponential is set equal to a number, and a third where an exponential is set equal to a number. Those may seem similar, but they're actually a little bit different. So we'll go over those last 2 in a bit. But first, we have an exponential of a same base set equal to an exponential of a same base. What do you think we can do? Ignore the bases, and 2x minus 9 equals 7. And then we solve for x. So I'm going to add 9 to both sides. 7 plus 9 is 16. And I'll divide by 2. 16 divided by 2 is 8. On exponential, you do not need to check for extraneous. Our answer is just 8. You guys try number 2. What makes 3 a little bit more tricky? There are 2 exponential functions on the left-hand side. Now remember, the rules are the same, but exponential is the opposite of log. So if we have 2 exponentials being multiplied, how can we condense them to be a single exponential? Add. Just like if we had x squared times x to the 4th. What do we do to condense those into a single exponential? You add the exponents to be x to the 6th. So same thing here. This exponential of 5 raised to c minus 1 times exponential of 5 raised to 3c plus 2, we can condense into a single exponential of 5 raised to the power of c minus 1 plus 3c plus 2 equals 5 raised to 7c plus 16. What do you think we can now do? Now I have an exponential set equal to an exponential. They have the same base. What can I do? We can just set c minus 1 plus 3c plus 2 equal to 7c plus 16. What could I have already done technically? Combine like terms. It doesn't really matter when you do it as long as you make sure to do it. What like terms happen over there on the left? Yeah. The c and the 3c combine to be 4c. And the negative 1 and the 2 combine to be 1. So we have 4c plus 1 equals 7c plus 16. What do you think I'd do next?
Get rid of the 7c, move the 7c over.
Sure, you can move the 7c over. And we have negative 3c plus 1 equals 16. And then subtract 1 over. And we have negative 3c equals 15. And then divide both sides by negative 3. So what is our final answer? C is equal to negative 5. I've decided I'm going to skip set 2 because all of those, well, should I? I don't think you're going to have something quite like this on your test, so we're going to skip this. All right. Next part, where we have an exponential set equal to a number. Let me do the hardest or a harder one first. Let me do number 5. What do you think I have to do first?
Is this the 9 raised to 4y minus 26, etc.? That problem?
E to the power of 3x plus 25 equals 108. That problem. It's number 5 on...
I see it.
Oh, you see it?
E to the power of 3x plus 25?
Yes. So what do you think we have to do first here? Yeah, you're trying to get the exponential term all by itself on one side, just like we got the log all by itself on one side. So we have e raised to the power of 3x equals, what's 108 minus 25? What is that? Thank you. Now what? We have the exponential term all by itself.
Make it into a log.
Now we do the opposite operation of exponential, which is log. Now what is our base in this problem? E. The base is E. So we take log of the same base on both sides. Log base E, log base E. What is log base E?
Natural log.
ln. You could have just written ln. Now log base c of e cancels, leaving us with what on the left? 3x equals log base c of 83. Which in our calculator, remember, log base c is the same thing as what? ln. So you can just do ln of 83. Yes, 4.42 if I'm rounding to the hundredths. Then what do? Divide both sides by 3. And I'm going to actually use that whole number and just divide by 3 in my calculator and get x equals 1.47 if I'm rounding to the hundredths. Any questions on that problem? As your last and final problem, and then you'll be done for today, which one do I want you to do? None of these are too bad. I guess I'll have you do number 3. Do number 3, and then you're done, and you can practice this next class, and you don't have homework.